So that's me. Been around in tech for quite a while, done quite a few things. And yes, that is the same shirt as I'm wearing today. That's either because my attention to detail is such that my bio picture has to match, or it could just be that it is my favorite shirt. So, wejo, connected car. Connected car, what is it all about? IoT, we've all heard the buzzwords, we all know a bit about IoT. Connected car is joining in, really. So yeah, the car's joining in on IoT. If you think about a modern day car, I mean, they know so much about what's going on. Everything's connected internally within the car. Windscreen wipers, lights, acceleration, how hard you're turning the steering wheel, a car knows that. Seat belts, people sat in the chair, who sat where, how much they weigh, whether you're sleepy, all sorts of things are appearing in cars as we go forwards. And we've also got this now they're getting access. So we're getting SIM cards in cars so that they can do things like they can download maps, they can interact, they can phone home, they can call an ambulance if you've had an accident, all sorts of things are happening within the car. And of course that opens up then an opportunity to get at that data in the car and use it in some sort of situation. And that was really the idea that started off wejo. The fact that actually all this data swilling around in the car could be something that we could use to really make mobility all round a much better experience. Get the whole world joined up so that we can share all this data, we can use it to improve congestion. We all love the green light button on the dashboard. We're probably not going to deliver that one, but dynamic flow of traffic through cities and all sorts of things like that. But it needs this car data, and that was the idea behind wejo when we started off. Starting in 2014, we're up to about 200 employees now, based in the northwest of England in Manchester and Chester. Got a footprint over in the US. So we've expanded quite a bit, spent a lot of time working with the manufacturers. Manufacturers, big companies, can be quite slow moving, but build a relationship with the manufacturers. And we've got about 15 million vehicles on the platform at the moment. Next year, hopefully we'll get up to 20-25 million or something like that. So that's the company. That's a bit about the context, if you like. Let's get a little bit more into the tech side of things. And by the way, I'm not selling you anything in this session. It's really just to share some things that we've done, share some of our challenges, talk about some of the tech, really, and that's what the point of this session is, really. So we ingest this data from these cars, and they're pushing this data through to us in near real time. So maybe every second, every 3 seconds, every 5 seconds. And that includes things like location information, that includes things like sensor statuses, and all sorts of different things are coming through. So we've actually got 2 OEMs on the platform in production, and then a couple more coming through into the sort of test phase. And one of those major manufacturers, US-based, both US-based at the moment. We are talking about to some European ones, but US-based. 9.2 million vehicles streamed in in every 3 seconds it is actually, so pretty much real time from our point of view. And then another 5.2 million vehicles and engine off. So send us some interesting things at engine off, and I'll talk about interesting things in a minute. I was going to title this like Big Data. We're at the Big Data conference. Surely it's a big data session, but then I thought actually there's going to be some very big data folk in here, so I'm going to coin the term quite a lot of data for this. Because big is a relative term, but to give you a feel for the sort of size and volume sort of thing, 17 billion data points, etc. The one that gets me, the one that I think actually gives us our most headache, if you like, is that 650,000 events per second. So that's streaming through the platform from these vehicles in real time at peak, which gives us a few headaches, to be fair. And then a growing data lake of 1.6 petabytes of data. So that, if you like, is what's coming in and what we've got to deal with, and and gives us our challenge, if you like. Yeah. So what is the data for the techies amongst you? So some IDs, as you might imagine, a timestamp, and then longitude, latitude, location of car, speed, heading, elevation, and a bit of information about the vehicle. That's an example of our movement data, and that's our most high volume data. So the data points I'm talking about, the 650,000 data points, that's the basic one. That's the standard one. There are other things mixed in with that data, as I alluded to at the start. There's a whole raft of other interesting things that they might send through to us. That's more sort of, a sensor-based or an event-based type feed, which comes through. You get a bit of a description about what it is. Some heartbreaking events is more of just a timestamp thing. Accelerometer, we get things like X and Y on the car. So if someone's cornering hard, maybe going around the country lanes, we get an indication of how hard they're cornering and that sort of stuff. There's all sorts of weird and wonderful things come through on this. So that's an example of the data that's coming through to us. Okay, so what do we do with it? So press the right button. So first and foremost, we do validation. So data quality, data governance, all that good stuff. And we have stream and we have batch data quality checks that we apply to this data. So fairly standard stuff from the point of view of making sure attributes are within bounds, that the speed isn't ridiculous, the lat long does exist on planet Earth, which obviously we do get stuff that comes out of space and all sorts of weird and wonderful stuff in the middle of the sea, all that good stuff. So we do some quality checks in stream. And then we do some additional stuff in batch. Now, it's quite hard. So what we're getting here is basically a journey. And so some of it is data point checks, and some of it makes sense in the context of a journey. So a journey check might be, duration of the journey. It might be consistency of data points against a road. It could be that sort of stuff, and that's quite hard to do in the streaming context. So we do a bunch of stuff in streaming before we send it out to some of our streaming partners, and then we do a bunch of other stuff in batch. We use Apache Spark for both of those. So we have a core library that we use, so we can do the classic stream versus batch implementation of that, get the same code base, use the same tech, works really well for us. Some points to note. We keep all the data. I mean, this is the great thing about AWS and S3. We can stick that into S3, we can glacier it off, it's pretty cheap to keep. And we keep that so that if we make a mistake or we need to go back and retrofit something. So one of the examples is a manufacturer might add an attribute and we might not be ready for it. So the stack is such that that attribute will come through, we'll keep that data in the raw, I'll just go straight through into S3. We won't bat an eyelid. But then we can retrofit it and add it into our aggregates or stats or whatever we might be if we need to. So that can sit in S3 for as long as we need it to. We can take our leisure, we can take a day, a week, a month. It depends on what the attribute is and whether we're super keen on it or whether it's something that's not very useful. So everything gets stored in S3, including the raw. And the other thing we've learned as well is we used to reject data. So if it failed some of our quality checks, we reject it. And actually now we've realized that depending on your perspective, you may or may not care about a bit of data. So if you're going to use the data for road planning, for example, maybe you're not interested in the fact that one of the seatbelt attributes hasn't come through correctly. So we don't reject the data packet, well, now we just flag individual attributes as being valid or invalid. And I mentioned already the core lib. The core lib takes all that logic and encapsulate for us. We also do some enrichment with this data, and this is where we start to get into the geospatial realm. So we do things like time zones as well. So okay, time zones. a bugbear of my life, really, in IT and dealing with time zones. But anyway, we have to deal with them. So, such that it is. I can't convince the US to consolidate on one time zone without any daylight saving. I wish I could. Managing of time zones and understanding where a lat long occurs. So calculating the time based on lat long, that sort of stuff we do. Geo-hashing. So now we're getting into the sort of map side of things. So that grid there is an example. So you've got 9Q8Y, that's that box, if you like. And then within the box, you've got sub-boxes that are all 9Q8Ys, but now you've got an additional letter on top of that. So based on the lat long, we boil that up to understand where it appears within the grid. Why do we do that? It's a lovely shortcut if you need to do filtering on geo very quickly. Because actually you can do a database query on that using, give me all the data in 9Q8Y, and you immediately get all that data without having doing any fancy geospatial stuff, without doing any complex joins or anything. It's just a very simple filter on some SQL. So we use that quite a lot internally. Data science use that. You can use it to do things like parallel processing as well. So if you need to distribute work out onto Spark, you can use that to partition the data, and you'll get some locality of the data within Spark processing. So there's all sorts of little tricks you can do with these geohashes. And then things like vehicle data, make or model and things like that. Obviously, manufacturers don't want to send us through a whole catalogue of information that actually is just reference data. So we can add that in if we need to share with partners. So you get it from the VIN basically. So every car has a unique VIN. We don't have the unique VIN. We have something called a squish VIN, which is just a partial section of the VIN. And from that you can do a lookup against various bits and bobs of information about the vehicle. Okay. Ooh, time. I thought I might be struggling for content rather than overrunning, but I'll make sure I don't overrun. So, what does it look like if you stick it on a map? So here we've got an individual journey that we've just really rendered it over the top of a map, so you can start to see. And actually on the left, it looks like a nice coherent, consistent thing, but probably still can't see it very well actually. But if you drill into it, it's actually just a series of dots on the map, and that's the lat long of these positions that the car's feeding through to us. So that's an individual journey. The problem is we want to deal with millions of journeys. So this is a little bit of insight into what we do. So geospatial joins, I've called it. So you've got these individual journeys, which are just dots in space, basically. And then you've got a source of maps, something like OSM. There are commercial ones. There's all sorts of different variations of maps out there. Here's another great set of maps. So using OSM as an example, use a bit of tech called Imposm, I don't know. OSM, import OSM really, so it's not that fancy. So we can use that to import into PostGIS. PostGIS, great tool for geospatial analysis of data. Fantastic features in there. Only slight drawback for us is that it can't accommodate our scale. If we stuck all our journeys in for a month's worth of data, the cluster, the size of a PostGIS instance it just doesn't make sense. But we do put subsets in, and we do put our map data in there, and we do use it to just help us. Really, it's a really useful tool. So that dotty thing there with a few lines through the middle is an example of the sort of thing we might have to deal with. And what we've got there is a car going through a journey where the GPS is a bit all over the place. And we've all experienced this. I always get it in London. I'm always lost. I get my phone out. The GPS is all over the place. I haven't got a bloody clue where I am. So I have to walk for 5 minutes for it to catch up. And then eventually it tracks me down. You get the same behaviours in cars. You get the same behaviours on the GPS. To be fair, that's a bad example. That's a worst case example. They tend not to be as bad as that. But just to illustrate the point, really. What we have to do with that is we have to look at that journey, and we have to decide which road on the map is it. And that black line there shows you've got a bit of a choice. So that journey, where's it going? Is it turned off, or is it gone straight on? Well, actually, of course, this one has got straight on, but what you don't know when you're looking at a point individually is where the overall journey is, because we're doing this in real time. So we have some fairly funky algorithms that we run in Databricks that we take this data and we use, you can do all sorts of things. You can use weights on roads, you can do all sorts of guesstimates around where you think this vehicle's going to go. But basically what we're ultimately going to get is, okay, that journey is along that road. So now we know that's associated to that road. So then we can sort of throw away the data points a little bit. We don't need the individual points. Now we're just going to deal with the fact we've got a road, we've got a journey, we've maybe got an average speed on that road segment. And then you do that more and more, and more and more, and more and more, and then you get this road index with all these journeys across it, and you get things like average speeds, you get average speed by time of day, you get traffic volumes, you can even do things like segment by type of car. Do certain types of cars go down certain different roads, who knows, all sorts of different weird and wonderful things. So what then you can do with that is you can stick it onto a map like that. So this is Austin in Texas. We have an office over in Austin. And this is using something called, there's a few different things going on in here. So Mapbox is the tech we've used for the map and the rendering of that. Ultimately, there's a whole set of little open source utilities you can use to do this in-browser rendering of geospatial data. Really good set. Kepler GL is another bit of tech that allows you to load in geospatial data and stick it on a map like this. And what you can see here is Austin. This is actually rush hour, and you can see the sort of traffic flow. Red implies slow-moving cars. So we've got a section of the sort of main artery through there you can see is all congested. So what? Well, if you're running the road network in Austin, this is invaluable information, especially when you start to sort of go, we had some roadworks on that day, or there was an accident over here, or there was an event going on, or whatever it might be. There's all sorts of different things you can then use to understand, actually, the reason we had a traffic jam on that particular day at that particular time is this. Or is it just fundamentally there's too much traffic on the road, and actually they need to invest in bike lanes, or whatever it might be, sort of thing. So that's the sort of visualization. Ultimately, when you've taken these individual data points, passed them through this entire stack, munched it together, a bit of Databricks magic, stuck it on a map, at that point you can start to get some really interesting insights in the marketplace. Okay, so just to summarize a little bit, not doing too bad for time. So growing data volumes in the industry generally, as people get more and more sensors available from these cars. And that's going to be a demand for us explicitly, but for all the manufacturers as well. Interesting times from a data engineering point of view, certainly. For us personally, that's an expanding platform, more and more features being added, more and more geospatial stuff being added. Geospatial is a very big growth area for us. It's interesting, I was wandering around, and actually there's not many folk around there talking about geospatial, which for my personal view is a bit of a pain, because I'm very interested in anyone who's doing anything geospatial, to be honest, because it's definitely, at scale, it's quite a tough nut to crack. If you think about it, IoT plus something that moves gives you your geospatial problem. So if you've got IoT for toasters or fridges, probably not that big a deal. As soon as you start tracking people or vehicles or anything that moves around on a regular basis, freight, anything like that, suddenly you're into geospatial analytics. So there's a whole different kettle of fish at that point. The plumbing slide of getting the data through to where you need to get it, it's only half the job. Actually, understanding the data that you've got out of that plumbing is actually then the really tough stuff. And when you've got a petabyte of data or more, doing analytics on that sort of volume starts to get quite tricky. Geospatial GIS actually is a very established, took me 5 minutes, very established world actually. There's a lot of great tech in geospatial. PostGIS was a good example of that. It's fantastic tech, but it's not being built in the big data era. So we've got this disjoint between big data, crunching these huge volumes. Tends to be great at temporal data, tends to be great at time series, or or traditional sort of data, relational data. Struggles a little bit with this geospatial side of things. And then on the horizon, of course, we'll have machine learning. Can't wait to basically stick this data into some machine learnings and see what we can get out of it, to see what we can predict on the road networks. Can we feed that into maps and use that for prediction of traffic jams, prediction of accident hotspots, all sorts of wonderful things we can start doing on that. It'll be quite interesting to get stuck into that. Some other bits and bobs. We are a stream first company, which it's a luxury of being a startup. A lot of companies have got a lot of legacy, they've got a lot of data warehouses and that sort of stuff. We started with streaming, and actually if you can move yourself into a stream first mentality, definitely initially it's quite a hard, tough nut to crack. But actually if you start with that, your data warehouse sort of falls out the back of it. But now it's up to date rather than being kept to date, rather than being a 24-hour cycle or anything like that. So we treat streaming as a first-class entity at wejo now, and it's the thing we focus our time and effort on. And actually using AWS, I'm sure it's the same experience in Azure. Getting it down onto disk and available for analytics is the easy bit. So stream first I think is very interesting and a great focus for us going forwards. Culturally as well, I think the other thing that wejo has really started to push hard on, we've got this plumbing, we've got this data, actually insight and knowledge, data science, growth of that. I mean, any data science amongst you, come and give me a knock if you want to do some geospatial analytics, because I'd definitely be interested. It's an exciting area for all of us really, but getting into the data and getting the insights out of that data and working with partners, visualization of it, etc., bringing it to life is a really exciting piece for us. So I think that's me done. Last one to mention actually on my list, I think I didn't really major on, I should have been in the other room for this bit if I wanted to talk about it too much, but governance and compliance. We spend a lot of time controlling, making sure everything's in the right place, making sure we've got an audit trail, data lineage, all that sort of stuff is a big deal for us as well. A lot of the manufacturers we work with, they are very, very risk averse. We have GDPR, we have the California protection stuff that's recently come in. All these things need to be factored in. And again, we have a luxury of being a startup. We can bake it in from the start, which has definitely helped us to get to where we are today. Okay then, thank you very much for your time. There's my details. Get in touch.